Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today we will discuss about friction related questions. So the friction is a part of engineering tribology subject. So majorly the engineering tribology involves friction, wear and lubrication parameters. So in this session, I want to explain about what type of questions they will ask in examination related to this friction topic. We will see with answers. The topic is friction. So first one is explain the term friction and causes of friction. So this type of question they will ask in definition and terminology also. But here you have to give some more explanation related to this friction and what are the causes of friction. The friction is the resistance to motion during sliding or rolling. That is experienced when one solid body moves tangentially over another with which it is in contact. Whenever two bodies are in contact, touch each other, so there is a friction. The occurrence of friction is a part of everyday life. In our daily life, you can see these type of frictions. So it is needed to so that we have control on our walking. Without friction, you can't walk. Friction is a force that acts to resist the motion of one object sliding over another. The friction is caused due to the causes of friction. So one is due to irregularities on the two surfaces in contact. So whenever there is a irregularity between irregularity of the surfaces, whenever these two surfaces are in contact, there is a friction. So suppose the smooth surfaces are there too, so there are no chances of friction. So when one object moves over the other, these irregularities on the surface get entangled, giving rise to friction. The more the roughness, the more irregularities and more significant will be the friction. So these are the causes of friction. So another one is rolling friction. So what do you mean by rolling friction? So the rolling friction is also known as rolling resistance, is the force that resists the motion when a body such as a wheel, a tire or ball rolls on a surface. When a body rolls on a surface, which force that resists the motion, that is friction. But the object is in rolling condition, that's why it is called rolling friction, rolls on a surface. It is significantly smaller than sliding friction, which occurs when two surfaces slide past one another, the primary mechanisms contributing to rolling friction. So deformation of the object and the surface. When a wheel rolls on a surface, both the wheel and the surface undergo some amount of deformation. For example, a rubber tire on a road will deform slightly, flattening where it touches the ground. So you can observe this example. Whenever the rubber tire on a road will deform slightly, this deformation creates a contact patch, the area where the tire and the road meet, and energy is lost due to the hysteresis of the materials. which is the energy loss associated with the repeated deformation and recovery. Micro sliding at the point of contact. Even though rolling involves rotation without significant sliding, microscopic sliding still occurs at the points of contact. So, without giving any sliding motion, the rolling involves. This type of contact is microscopic at the point of contact. This is micro sliding. This micro sliding results in small frictional forces that contribute to the overall rolling resistance. Next, surface roughness and imperfection. The surfaces of both the rolling object and the track may have imperfections and roughness. These irregularities cause additional resistance as the object moves, leading to energy losses and contributing to rolling friction. So, the irregularities cause additional resistance as the object moves. So, due to surface imperfections and poor surface finish. Next, adhesion. The molecular forces of adhesion between the rolling object and the surface can also contribute to rolling resistance. So, this is more significant for materials that have a higher tendency to stick together, such as rubber on a asphalt. Next, internal friction within the rolling object. The internal friction within the material of the rolling object itself, like within the layers of a rubber tire, can contribute to energy loss. This internal friction is due to the viscoelastic properties of the material, where energy is dissipated as heat during deformation. Next, factors affecting the rolling friction. So, what are the factors affecting the rolling friction? They will ask examination questions like this. What are the factors affecting rolling friction? So, here, what are the factors affecting rolling friction? So, the one is material properties. Another one is radius of the rolling object. The softer material tend to have higher rolling friction because they deform more, leading to greater energy loss. Next, radius of the rolling object. Larger wheels tend to have lower rolling friction because they deform less relative to their size. Next one is load. The greater loads increase the deformation of the rolling object and the surface, increasing rolling friction. Speed. At higher speeds, the frequency of deformation increases, leading to more significant energy loss through internal friction and hysteresis effects. Next type question is explain the mechanism of rolling friction. So, what is the mechanism behind this rolling friction? So, here given the rolling friction example. So, the wheels easily move the cart. So, with in the case of suppose if you're not having this the wheels not having this cart. So, here some friction will be developed between the surface and this cart if not having the rollers. The applying force also very less when compared to without with rollers. So usually you can move this cart on a surface due to the less friction. So less resistance force will be occurred. So here see in the wheel, the rolling wheel friction resists the sliding. The push on wheel, the wheel rolls forward in this direction, but the opposite force, the friction resists this sliding. So this allows wheels to turn by pushing back to tire moves forwards. So example, bicycle and car. So another one more example here, unstreamlined and airflow of our vehicles, streamlined airflow. You can see in this diagram figure. When you ride your bike through water, there may not be enough friction between the tire and the ground to move forward. And so the bike skids. So if not having friction between the tire and the ground, it may be skid or slides of balance. So air pushes against you, acts on the forward moving part on an object. So front of a car acts on a forward moving part. So when you ride the bicycle, or air pushes your air and close back. So whenever you are going by bike, you can observe this air resistance. So shown in this figure, rolling friction, the push on wheel, the wheels rolls forward and friction resist rolling. Already we have seen in the previous slide. So this one also example for rolling friction. So when you are going by bicycle, the air resistance will be occurred due to the airflow. You are moving opposite to the airflow, and this force acts always downwards gravity, and our applied force, the normal force acts upward. So that's why the frictional resistance force always mu r, F is equal to mu r. So directly proportional to the normal reaction force. So you can write with the help of coefficient of friction, F is equal to mu r. So rolling already given in this slide. So normal force and rotational velocity and translational velocity. So rolling friction shown in this, and acceleration due to gravity always acts downwards. And the applied force also you can see in this diagram. And mass and sphere. These diagrams have taken from the college search website. These are the reference we have taken. So let's discuss about adhesion theory of friction and its importance. So what is the adhesion theory? The adhesion theory of friction posed that the frictional force between the two surfaces in contact is primarily due to the adhesive forces at the microscopic contact points, known as asperities, where the surface touch. This theory contrasts with the older view that friction is mainly due to mechanical interlocking of surface roughness. So this theory due to the mechanical interlocking of surface roughness. So what is this adhesion theory? So the frictional force between the two surfaces in contact primarily due to the adhesive forces at the microscopic contact points, when the two surfaces are contacting each other due to their the material properties also. The key concepts of adhesion theory is in given here microscopic contact points. The real surfaces, even if they appear smooth, have microscopic roughness. The actual contact between surfaces occurs at these microscopic asperities, resulting in a smaller actual contact area compared to the apparent microscopic contact area. The adhesive force. At the aspirates, adhesive forces, example van der Waals forces, metallic bonding, act between the atoms or molecules of the two surfaces. These forces create a resistance to sliding, contributing to the frictional force. Deformation and shearing. When a tangential force is applied to move one surface over the other, the aspirates deform and shear. The energy required to shear these microscopic contact points contributes to the overall frictional force. So next, plastic and elastic deformation. Depending on the materials, the aspirates can undergo elastic reversible or plastic. The plastic is permanent and undergo elastic reversible deformation. So the elastic deformation gives only temporary changes in the shape. But in case of plastic deformation results in permanent changes, increasing friction. So whenever material subjected to this elastic deformation, whenever you release the load, then regain its original shape. But in the case of plastic deformation, not like that. So occupies permanent changes. Importance of adhesion theory. Explaining different material behaviors. The adhesion theory helps explain why different materials exhibit different coefficients of friction. Materials with high adhesive forces at the microscopic level tend to have higher friction coefficients. The surface treatments and coatings. Understanding the adhesion theory aids in developing surface treatments and coatings that reduce friction. For instance, lubricants create a thin film that reduces direct contact between the aspirates, lowering adhesive forces and thus friction. Next, wear and durability. The theory provides insights into wear mechanisms, as the shearing of aspirates can lead to material transfer and degradation. So, improving material properties to reduce the adhesion at contact points. So, you can improve to enhance the material properties. Whenever you enhance the material property, then you can reduce the adhesion property at contact points, can enhance the durability and the lifespan of the mechanical components also. So, nanotechnology and micro scale applications. At the micro and nano scales, adhesion forces become significantly more prominent. The adhesion theory is crucial in designing and understanding the behavior of electromechanical systems, that is MEMS, and nanotechnology applications, where friction and wear are critical factors. So, biological systems. The theory is also important in understanding biological systems, such as the adhesion of gecko feet to surfaces. This knowledge can inspire biometric designs for applications requiring strong and reversible adhesion. So, biological systems. So, this is important in understanding the biological system, such as the addition of gecko feet to surfaces. Let's compare the friction properties of metallic and non-metallic materials. The friction properties of materials can vary significantly based on their composition. So, they will ask questions like this: compare the friction properties of metallic and non-metallic materials. So, the friction properties can vary significantly based on their composition, structure, and surface characteristics. Here is a comparison of the friction properties of metallic and non-metallic materials. So one is metallic materials. The properties, high hardness and strength. So the metals generally have high hardness and strength, which affects how they interact at contact surfaces. Next, conductivity. So metals are good conductors of heat and electricity, influence the frictional heat generated during contact. Similarly, surface oxidation. The metals can oxidize, forming surface films that can alter friction properties. Next, friction characteristics. Friction characteristics are one is a higher coefficient of friction. The metals typically exhibit higher coefficients of friction due to strong adhesive forces at asperities and the potential for cold welding. The surface roughness. The inherent surface roughness of metals contributes to higher friction due to mechanical interlocking and increased real contact area. The lubrication sensitivity means metallic surfaces often require lubrication to reduce friction, and whereas lubricants can significantly lower the coefficient of friction by preventing direct metal to metal contact. So, whenever you apply lubrication, you can prevent the metal to metal contact. In initial stage, there will be chances of metal to metal contact. Whenever you slowly supply the lubricant in between the surfaces, so they will separate. So the lubrication film formation will be happening in between these two contact surface. So you can see this type of experience in the lubrication theory, hydrodynamic lubrication theory. Next, temperature effects. Frictional heat can cause thermal expansion and softening of metals, leading to changes in friction and wear behavior. So non-metallic materials. The properties are variety of compositions. So non-metallic materials include polymers, ceramics, composites, and more, each with distinct properties and insulative properties. So many non-metallic materials are insulators of heat and electricity. And elasticity and plasticity property. The non-metallic materials often exhibit greater elasticity or plasticity compared to the metals, affecting how they deform under load. Next, what are the friction characteristics of these non-metallic materials? The variable coefficient of friction. The coefficient of friction for non-metallic materials can vary widely depending on the specific materials. Polymers, for example, typically have lower coefficients of friction compared to metals, while ceramics can have higher coefficients. Next, surface characteristics. Non-metallic surfaces can be smoother or more compliant, reducing mechanical interlocking and real contact area compared to metals. Self-lubricating properties. Some non-metallic materials like certain polymers, example PTFE or Teflon, have inherent self-lubricating properties. They result in low friction without additional lubricant. No need to supply of the extra lubrication. So not required any lubrication mechanism. The material itself having the self-lubricating properties. The temperature stability. Non-metallic materials like ceramics can maintain stable friction properties at high temperatures, whereas polymers might degrade or soften, altering their friction behavior. Next, wear resistance. Ceramics and certain composites exhibit excellent wear resistance and maintain their friction properties over extended use. while softer non-metallic materials like some polymers may wear faster. So these are the references I have taken for this friction topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.